For centuries, fictional depictions of planets orbiting other stars have fired our imagination. From the desert world of Arrakis and Dune to the lush jungles of Yoda's planet Dagobah in Star Wars. We humans have been fascinated with the idea of exotic far off worlds. We now know that worlds beyond our solar system, known as exoplanets, do exist. In fact, there are a whole lot of them. Scientists have found over 4,000 exoplanets and think that most stars have their own solar systems. Some exoplanets are surprisingly similar to fictional worlds we have imagined, while others have turned out to be more exotic than anything we could have dreamed of. There are lots of reasons to learn about exoplanets, but perhaps the most compelling is that we could find another world that hosts living organisms. If we discover life beyond Earth, it could change the course of human history. And with continual advancements in exoplanet research, this discovery could happen in your lifetime. So, what are exoplanets? An extrasolar planet is a planet that orbits a star that is part of a solar system other than our own. Our solar system is only one among billions, and many of them most likely have their own system of planets. As early as the 16th century, there have been astronomers who hypothesized the existence of extrasolar planets. So, how do we study them? Even through a powerful ground or space-based telescope, stars look like tiny points of light you see every day in the sky. Planets are even tinier and are very difficult to spot next to their bright host stars. Therefore, scientists rely on indirect methods, like looking at the stars themselves for signs that planets might be orbiting them. There are three main detection techniques that can be used to find extrasolar planets. All of them rely on detecting a planet's effect on its parent star to infer the planet's existence. The three techniques are simple in principle but difficult in practice because extreme precision is needed to register the planet's effect on the much larger star. This is also difficult from Earth because the atmosphere distorts our view of the stars, limiting the accuracy of the observations. While some exoplanets have been observed directly with telescope, a process known as direct imaging, the vast majority have been detected through indirect methods such as the transit method and the radial velocity method. In the case of the transit method, a planet is observed when crossing the path, that is, transiting in front of its parent star's disk. When this occurs, the observed brightness of the star drops by a small amount. This can be used to determine the radius of the planet and can sometimes allow a planet's atmosphere to be investigated through spectroscopy. However, it also suffers from a substantial rate of false positives and requires that part of the planet's orbit intersects with the line of sight between the host star and the Earth. As a result, confirmation from another method is usually considered necessary. Nevertheless, it remains the most widely used method and is responsible for more exoplanet discoveries than all other methods combined. Both the Kepler Space Telescope and TESS were specifically designed to conduct this kind of photometry. Even the latest JWST, the James Webb Telescope, uses transit method for detection, but it will also use direct imaging technique using spectroscopy. There's also the Nancy Grace Roman Space Telescope, a successor mission nicknamed the Mother of Hubble, which is planned to launch in 2025 for exoplanet search. One of the main goals of exoplanet search is to planets that resemble Earth. You'll often hear the term Earthlike, used to describe worlds that resemble our own. Generally speaking, this means the planet might have liquid water and atmosphere that could support life as we know it. Life on other worlds may be unrecognizably different from what we know here on Earth, and even life on our planet is extraordinarily diverse. But it makes sense to start by looking for worlds that resemble our own, right? The most basic condition for being able to sustain liquid water is the planet's position in relation to its star. Scientists call the region the habitable zone around a star where liquid water can exist on the surface of a planet. Not so close to the star that water all evaporates, and not so far from the star that it all freezes. The first exoplanet confirmed by Kepler to have an average orbital distance that placed it within its star's habitable zone was Kepler 22b. This planet is located about 600 light years away from Earth in the constellation of Cygnus and was first observed on May 12, 2009. Based on all the data obtained, scientists believe that this world is roughly 2.4 times the radius of Earth, following which there have been several Earth-like exoplanets found that resemble Earth in some other way, and the estimates of habitability has been calculated, though none of them fulfill the numbers completely yet. There could be as many as 40 billion planets in the habitable zone of stars right here in our Milky Way galaxy. So far, we've found about 20. That may not seem like many, but consider this. It's possible that we've already found a planet that hosts life, and we just don't know it yet. It is rightly said that there's an entire universe of worlds out there to discover, and we've barely scratched the surface.